Okay, let me just start this running real quick and see where we left off. So how did the homework go? Easy? Trivial? Are we missing a bunch of people?
There's good. Tim went to get his laptop.
Oh, I saw Tim just a little bit ago. Are we missing other people other than Tim? Yeah. Those people must be so forgettable. Oh, Stanton is pretty ill, so I know he's not going to be here.
He's at work.
Yeah, but I talked to him after that. Yeah. No, it's legit. It's legit. He's good. Okay, so we have this guy here where we might put in something like add x0, x1, x3, whatever, and this would add the contents of x1 to the contents of x3, storing the result in x0. So when we hit execute, that should happen, right? All right, so we need to do a couple of things here. So first we need to write some sort of parser that'll allow us to parse out our instructions, right? Now, at some point as we go down the line here, we're going to start just doing this at a high level, but we're going to connect this back to the book where our actual instruction starts off as a 11-bit value. Remember, we basically have an instruction set that we have the potential for 2 to the 11th number of instructions in the ARM instruction set. That's the possible maximum number of unique instructions, unique magic tricks, because we are storing it as an 11-bit data field. And then each of our registers here are represented as 5 bits, right? And then wasn't there, I think it's a 7-bit shift field. Was it 7 bits? 6 bits? 6-bit shift field that is ignored for us right now. Okay, so we're going to go ahead and write our parser that's at least going to split this guy up, right? So right now we have an instruction. Well, here, let's just start writing it, and then we'll think about how this guy is going to work. All right, so here's our execute button, this guy right here. So he's going to read in from that execute line. So that's in here. What did I name it? Like execute something? Well, that's the function, but instruction ET. I named that guy instruction ET. All right, so we need to make sure we give ourselves access to instruction ET in here. Have we already done that? We have, well, at least I haven't. Hopefully all of you have. All right, so I'm going to give myself a private variable. It's going to be an edit text. It's going to be, I'm going to call it instruction ET for right now. Then we're going to go ahead and actually hook that guy up. So we'll say this dot instruction ET is equal to the edit text version of this dot find view by ID r dot ID dot instruction ET, this dude. All right, so we'll connect that guy up. All right, and just real quick, just to make sure everything is actually linked together pretty well, I'm going to just come in here to my why isn't it that kicking it down a line? I've hit something that must be bad. There we go. All right, so I'm going to, when I hit the execute button, I'm just going to set that edit text to some text just to prove that everything's hooked up, that my button's clickable, and that my edit text is linked, so I know that's working. So I'll say this dot instruction ET dot set text to LOL. All right, and then let's go ahead and make sure that we have the on click set for that button. So here's our execute button. We'll choose our execute button pressed for the on click. So now we've completed the MVC hookup. Button calls that function, and my code, my controller knows about my edit text. Okay, so let's run this real quick and make sure those guys are all getting called in the right order and all that jazz. All right, so just hit execute, and that changes to LOL, so everybody's happy. All right, now, just so we don't have to, as we're testing, just so we don't have to type stuff in a whole bunch of times, I'm going to put some default text into my enter arm instruction box. So I'm going to say add x0, comma, x1, comma, x2. So kind of test instructions, so I don't have to type that every single time I launch the app. All right, so now what we do is when we hit execute, we want to go ahead and read this in, and we want to get the individual pieces, right? So now what we know here is that we're going to have the instruction first, followed by, you can make the assumption that it's exactly one space, or we can say it's white space, but certainly there's at least one space between the instruction and our destination register, correct? All right, so we need to go ahead and parse through this string. Now, can we make assumptions that there are actually spaces between x0, x1, and x2? This is actually a legal line of code if I do this. So I can say x0, x1, x2 with no spaces, and that's legal. All right, so I know there's a space between my instruction and the collection of parameters, let's say, but the collection of parameters is actually comma delimited. Make sense? Okay, so we're going to first, now we could say, well, could we split on spaces? We might say that. Well, not necessarily, because we split on spaces, then what do we run into? If we have a space here, let's say I put a space after this comma, something like that. Let me put a couple more spaces so it is obvious. All right, so if I say split this guy on spaces, I'm going to get 3 pieces. This is bucket 0, this is bucket 1, all this is bucket 2. Also not what I want. So really I need to find the location of the first space, right? And figure out what the instruction is. So let's start with that. So I'll leave it like this for right now, just so we can test against spaces. We'll come into main activity. Now, I'll go ahead and get our instruction into a string, just to say we have it. So string instruction is equal to this. Why did it bounce up there? Well, I'm sure it was user error. This dot instruction et dot get text, which is going to give me this thing of type editable. And I'm going to say dot toString. That gets me the string version of that editable thing. Interestingly, let me just teach you something else here real quick. So notice get text returns something called editable. So what kind of animal do you think editable is? In the big scheme of, well, in this case, it's Java programming, what is editable? What kind of animal is that? Okay, well, that's true. It's not an instance of the string class. Okay, the question I'm really asking here has something to do with naming conventions. So it starts with a capital letter, first of all. So when it starts with a capital letter, what do we initially think it might be? A class. So it starts with a capital letter, we think it's probably a class. In this case, it's actually not. Anybody know what it is? Actually, I've never actually looked this up, so we're going to test me here in a second to see if I'm right. But I feel pretty confident that I'm saying it out loud and on recording. Yeah, don't look it up, though. I want you to tell me. Editable. Yep.
So it's one of those things that ends with able. So
it is something that ends with able. So that's the naming convention. Something that ends with able, like runnable is another example if you've dealt with multi-threads in Java before. Okay, so these guys are interfaces. Okay, these are interfaces. So if we just go and let's test ourselves here. Editable Android API, something like that. Yeah, public interface, editable. Okay, so I get another extra credit token. All right, so public interface editable. What's an interface? Anybody else know? I'm pretty positive she knows. If you've had 300, we definitely dealt with it. How many of you at least remember that we've talked about editable before? A couple of you haven't had 300, so you wouldn't have seen it. Kind of remember it, but not sure what it is. Okay, so, well, here, go ahead. What's editable? Or what's interface, rather?
Interface basically creates a template for which classes are held off. It doesn't have any. It holds like the names of the methods and stuff you have, but it doesn't have the body.
Yeah, so it dictates what you must build. So editable dictates what you interface dictates what you must build. So, for instance, this editable interface says that you must write a method called append and clear, so on and so forth. Actually, some of these are going to come in as inherited methods. It'll tell them down there. But anything that is defined inside of an interface says that anything that is going to implement this interface. So we implement interfaces, we extend classes through the inheritance model. So anything that's going to implement an interface now has to follow the rules and write those functions. Okay, that way, like for instance, we could say that a keyboard. When you buy a keyboard off Amazon, you're making an assumption that it has at least all of the default keyboard stuff, right? So somewhere there can be an interface that says this is what a computer keyboard is. It has to have all the keys for all the letters and the numbers and that stuff. Okay. Now, some keyboards have a little bit more than that, right? Some keyboards are like gaming keyboards and they have like rapid fire buttons and programmable stuff and things like that. But everything that is a keyboard follows that there's some default template. So when you're buying a keyboard off of Amazon, how many of you waste your time checking to make sure there's an A key? Okay? You assume there's an A key on there because this dude's claiming to be a keyboard. So it's following the rules of the keyboard interface. That makes sense? That's what an interface is. Not really related to this class, more of a programming thing, but since I saw the word editable there, I figured I'd point that out. So get text actually gives me something that is an editable. And then if I want to get the string out of that editable, then I can say toString. All right. So there's my instruction. So that's the whole line. So right now, instruction, this would hold something in our world right now, like add x0, comma, x1, comma, put some spaces in there, x2, something like that. It would hold a string that looks like that. All right, so we want to write the necessary code that will extract the add for us. How would I do that?
Substring.
Do what now?
Substring.
Substring. Okay, what's substring?
Instruction substring, and then from the index 0 to index 3 or something.
Okay.
No.
Okay, so let's write that. So we're going to say string magic trick, and we're going to say this guy is instruction dot substring starting at 0. This is bucket 0, 1, 2, 3. So up to 3, but not including 3 is how substring works. Okay, go ahead.
But what if we?
I'm about to ask what's wrong with this. Yeah.
Yeah.
Okay. So the problem with this would work for add, right? So if we want to prove that here, we'll just go ahead and we'll say this dot instruction et dot set text to whatever our magic trick is. So let's just see this real quick. So if I hit execute, we see that it got the add. Retrieve the add. Isn't it true that got is not a word or something? Whatever. It got the add. All right, so we have add there. Now, as he pointed out, what if it was add I? If I run this guy again real quick, and I update my instruction ever so slightly. So it's no longer just the add instruction. Now it's the add I instruction. Notice we still just get add. So we're making an assumption about the length of the instruction. Okay, so while this would work for add specifically or any other 3-character instruction, this isn't written generically to work for any magic trick, right? We know that the magic trick will be followed by at least one space, right? So do we have a way of finding the location of the first space?
Well, space is a character.
Huh?
Tokenizer.
Okay. We could use the string tokenizer if we are gluttons for punishment. That's true. Do you have a better way? You pointed out that a space is a character. That's true. So how can we find the location of the first space? Okay, could write a for loop. Let's write that first. Okay, because that's important. I want that to come to mind first. Because I don't always want you to assume that there's a power tool that will do everything. All right. A for loop to search for a space is not that big of a deal, right? So we're going to go ahead and we're going to say for int I is equal to 0, I is less than instruction.length, I++. So we'll potentially go through every element of our string there. And I'm going to go ahead and define my string magic trick before this and just set it equal to the empty string initially. And we can say that because we know the nature of our data here, we know that we will hit a space before the end of this string. All right, so inside here, so we're going to go through potentially every character in the string. We're going to ask the question, if the character I'm currently looking at, which is instruction.charaddI, if that particular character is equal to a space, that means I'm currently looking at a space at bucket I, right? Which is the last, which is, because of the way substring works, is the bucket that I want everything up until but not including. So I would say magic trick is equal to instruction.substring from bucket 0 to bucket I. And then I can go ahead and break out of the loop. So I'll potentially go through my entire instruction. I will look for a space. As soon as I find my very first space, I'll grab my magic trick by getting the substring from bucket 0 up to the current position I am, but it won't include that position. So it'll be everything up to, but not including the space I just found. I'll store that in magic trick. I'll break out, and then we'll put magic trick in our edit text proving we found it. So let's go ahead and run this. We'll see this works for add. We'll see it also works for add I. All right, so I'll execute this real quick. There's my add. I'll run it again. I mean, I could just type it in there again, but we'll just do this. And I'll throw an add I in there. There's my add I, and we see it works for that as well. All right, so this is a perfectly viable way of doing this. Anybody have a replacement way? Instead of doing it this way, what can we do? See if anybody else comes up with it first. Or did everybody do it this way? Or did everybody just hard code in a 3? Do we at least get that hard coding in a 3 isn't, while it would have worked for this assignment, that's not the way you should do it because it's not generic for all instructions. It's important that you at least make that connection. I'm not going to take points off in the assignment. Technically, you just had to make it work for add. But we get why that's a problem? Go ahead.
Could we use index of?
We could use index of. So he wants to say magic trick is equal to this dot instruction et dot substring. I'm sorry, not instruction et, just instruction. Instruction dot substring from bucket 0 to bucket what? You said you want to use index of, so tell me how to use index of here. What does index of do first? Remind me.
Index of takes in a character and returns the first position of that character within a string.
Yep.
Otherwise, -1 if the string
Yep.
if that character is out.
Perfect. Yeah, because that -1's a really important piece, right? So index of searches the calling string. So it's an instance method. Okay, it searches the calling string for the location of. There's two versions of index of actually. It's either a char or you can also give it a string to search for. But we're going to use the one that takes a char. So we're going to search for the char space, and it will return an integer that is the location of the first occurrence of space in that string, or a -1 if it never found it. So we will say instruction dot index of space. That's going to be the second parameter of our substring function. So this guy right here, instruction dot index of space, in example of add, would return a 3. Make sense? All right, so that'll boil down to a 3. So this will give us index from 0, or a substring from 0 to 3. If this was add I, it would return a 4. All right, so by doing it that way, we can avoid this for loop and still get our magic trick. So there's our add. Bro, did I do that? I don't think any of my code is bad. Oh, I must have hit execute a second time. Yeah, because if I hit it again right now, it should. Yeah, it's not happy. So I'll go ahead and do add I. We'll see that it still works. And there's our add I. Okay, so this is us extracting the actual magic trick. Now we need to go ahead and get the source. Well, now we need to go ahead and get the registers is what we need. So I have the magic trick, but now I need everything after the magic trick. Now I already know the location of the first space, don't I? So I could store that somewhere, right? Couldn't I say int location of first space is equal to this dude? Like that. And then in here, I can just use location of first space. It's my second parameter to substring. So what is the rest of my instruction? Where's my collection of parameters going to be located? From the location of the first space to the end, the rest of it, right? So we'll create a string here called string the rest, and this is going to be instruction dot substring from location of first space. So that will start from that position and go all the way to the end. Give me everything but my magic trick, which with potentially some spaces. Right? So if I have some spaces in the front and I have some spaces in the end, do we have a built-in function that lets me get rid of those spaces? What's it called? It's a pretty common one. Most languages have this guy. Split allows me to break stuff apart. I'm saying, what if I have a string that looks like this? Whatever, we'll just have some misspellings. What if I have something that looks like this and I want to turn it into that? Do I have a built-in function that will do that for me? What's it called? Trim. Okay, so I can say this dude, that's going to be a string dot. Gotta spell it right. Trim. All right, so trim will get rid of all the leading spaces and get rid of all the trailing spaces. It won't remove the spaces in the middle. Just so you're trimming both ends. Get it? Okay. Pretty common function in most programming languages. We have something called trim that you can usually rely on being there. Otherwise, we could have written a little function that went and built your string, right? And then done the other side, so it would have not been as friendly, but this will do it. All right, so now I have the rest. So the rest of my function will ultimately look like, so let's just write what this might look like. So I'll just put in x0, x1, x2, something like that. And this would produce for me x0, x1, x2. So that's what would be inside of my string, the rest, after that line. Okay, now I want to break that guy up into my pieces. Okay, now I happen to know that my parameters in ARM are separated by commas, correct? Okay, so now, as Charlie pointed out, I can split on commas, right? Okay, so I'm going to go ahead and we're going to create a string array called parts, and this will be equal to the rest dot split on comma. All right, and what this will give me is an array where bucket 0 is x0, bucket 1, actually let's write this as a string. Bucket 1 in this case would be x1 like that, and bucket 2 would be x2 like that. So that would create for me a string array with those three pieces. That's what split on comma would do if the string I was splitting was that guy. Make sense how that's working? Okay, so now I know that my destination register is the guy that lives at bucket 0, the trimmed version of the guy that lives at bucket 0. Because we can already see that bucket 1, I'm going to definitely want to trim the spaces off either side of that, right? So I could just assume that there might be spaces in all the pieces and just trim it. So now I can say, for right now, we'll just assume there's 3 parameters. Some of our instructions we know have a different number of parameters, so we might want to operate directly off the list. Yeah, so let's write it specifically for add right now, or for 3 parameter instructions, and then we'll make it a little more generic later. So I'm going to say string destination register is going to be equal to parts at bucket 0 dot trim. So the trimmed version of bucket 0 of parts. So in our example here, this would give us a x0, like that. Then string input 2, because of the way they ordered them, is equal to parts at bucket 1 dot trim. String input 1 is equal to parts at bucket 2 dot trim. All right, so there's our pieces there. So now I have the pieces. So I know that the name of the register that I want to store my stuff in is destination register. I know that the name of the register I want to get one of my numbers from is called input 2, is stored in input 2. Let's call this input 2 register. Input 1 register, just to keep reminding us these are actually names of registers. In fact, I'm actually going to call this destination register name, input 2 register name, input 1 register name. I know these seem like very verbose variable names, but might as well keep things straight. All right, so that guy would be x0. This guy in our example would be x1. This guy in our example would be x2.
Why do you call it input 2 and then 1?
Because it actually, the way they are stored in the instructions is backwards. It's going to make a difference when we do subtraction. So in subtraction, I believe it is you will subtract x2 from x1, storing the result in x0. Pretty certain that's the way it actually does the math. We'll confirm in a few minutes, but I'm pretty sure that's the way it does the math. Okay. And the reason for that is the math is done on a stack. So it'll actually take input 2 and it'll push it onto a stack. Then it'll take input 1 and push it onto the stack. Then it'll apply the function that it's going to do to it. So it has to do with reverse Polish notation for that kind of stuff. Okay. So now I have my individual pieces. Well, now I know what I'm doing. I know where I'm putting the result, the name of where I'm putting the result, and I know the name of where I'm getting my 2 inputs. Now I got to create some functionality to go and look up the actual registers where those things live, right? So I need to be able to find registers given their name. Okay? So right now my registers are stored inside of ARMap, right? I have an array of registers here. So could I write a function that says find register by name or find register given name or something like that? That would return a register for me. Could make some sense, right? All right, so we'll go ahead and we'll write that function. So we'll say public static. This guy's going to return a register for me. So I'm going to look up a register given its name. We'll call this guy find register with name. And this guy will take in a name of register as a string. And then what I'm going to do is, now we could presume, well, actually, we don't need to presume in this case. We can, from an error checking perspective, we can assume that they're going to pass us the name of a legal register. Okay, but we're going to still have to have this guy has to return something in the event that I don't do anything, that I don't find it. So we'll just write it generically so we don't have the issue. So I'm going to go through all of my registers inside of my register array. Right? Now, technically, I don't have to know what bucket I'm looking at here, right? So I can actually use a for each loop to go through these guys. So I'll say for register R in registers. And I'll actually say ARMap.registers, just because I like being complete like that. It'll actually be a little bit faster. So for register R in ARMap.registers, why didn't I need to put ARMap in front of this guy? Well, registers is static, right? This variable is a static variable. It's owned by the class, and I'm operating from a static context. Therefore, it's presumed that I have ARMap dot in front of things that are in there. So it wasn't required, but it's never wrong if you put it. All right, and it'll be a little faster because you're not requiring it to do a scope lookup. All right, so this will iterate through every register inside of my registers. So each time through, R will be equal to the next register in there. And then I want to ask a question. Is R's name the name of the register I'm looking for? So if R dot get that's number human readable name, right? So get my human readable name. If that guy dot equals name of register. Okay, so we're comparing strings, so we're going to use the dot equals function, not the double equal sign. Okay, because if I use the double equal sign for comparing strings, what am I actually comparing? Yeah, so if I have the string hello, and I'm saying, is this guy equal to the string hello? We might say, well, yeah, both of these say hello. The reality is That's not what it's actually comparing. It's comparing the memory address of these guys. So just to review that real quick, if I had a string s is equal to hello, and I had a string s2 is equal to hello, and I had a string s3 is equal to a new string hello, s equal s2 would boil down to true, but s equal s3 would boil down to false, because the new keyword is my real estate agent. It gets me new memory. So when I first create these strings, it's going to, well, when I create this string, it's going to, assuming this is the first time the hello string literal appeared in my program, it'll create memory and put it there. When I create this string here, it's going to notice, oh, you've already used the hello string literal before. So rather than taking up extra space, I'll just make s2 point to the same place in memory as s points to. That's why s equals s2, because they both hold the same memory address. They both point to the same place in memory. They are the same object. But since I explicitly used the new keyword for creating s3, I'm saying ignore the fact that the string literal hello already exists. Go ahead and find me new memory and put the string literal hello there. So s3 actually points to a different place in memory than s1 or than s and s2. So s equal s3 is false. These are not the same memory addresses. Whereas s equal s2 is true. Both of these guys are the same memory addresses. What I really want to compare here is not their memory addresses. I want to know if the name of this register has the same contents as the name of the register string I passed in. Do both of them say X0, for example? Does that make sense? Okay. Important concept, because this is something that will haunt your dreams at some point when you get a bug in your program and you don't know why.
I wonder if you keep giving me error.
Yeah. But it won't be an error. You'll just get false positives, right? You'll say, oh, are these two things the same? And the answer might be true when you actually want it to be false, because they're different objects, or vice versa. You might want to say, are these the same object? And you want the answer to be false, but you actually get it true because they point to the same place when you actually care about the contents of them or something like that. All right, so I'm going to go through all my registers. I'm going to ask, is the readable name of the current register I'm looking at, is that guy equal to the name of the register we passed in? If you want to give them a little wiggle room to use case insensitivity for the registers, you could say equals ignore case. There's a version of the equals function that will ignore case. That way they could pass things in like x0, and that would match up to a register named x0. It would return true for those things, whereas just equals would not. They need to be case sensitive equivalent. So you can choose here how flexible you want to allow your ARM programmer to be. If you want to let them reference registers using upper and lowercase x, then you can put ignore case. Do we have an opinion? We forcing uppercase, or we let them do whatever? Very Microsoft of you.
We should force them to write the register names in hexadecimal.
You got to put the hex register names?
Yeah.
Right. It's a good idea for an assignment. Thank him later. All right. All right. So if it's the register I'm looking for, then I'm going to return R. Because ultimately the job of this function is to return the actual register object of the register that matches this string name. Okay. If for some reason I got through this whole thing and I never found the register because you sent me some Klingon name or something like that, I'll just return null and that'll just be somebody else's problem for right now. We're not going to do any error checking. So our function here presumes you will pass it a legitimate register name and we will find it in our for loop here. Make sense? Okay. So now my AR map has a class method called findRegisterWithName, so I can use this guy to look up my registers that are involved in this particular math thing. So I'll go back here to our main activity. So these are my three names. Now I'll get the actual registers. So I'll say register, destination, register, 2 I's. How many I's are in destination? Destination register is going to be equal to ARMAP dot find register with name, destination register name. So that'll look that guy up. Then I'll say register input to register is equal to ARMAP dot find register with name, input to register name. And then register input 1 register is equal to ARMAP dot find register with name, input 1 register name. So use my function I just wrote there to look up my three actual registers. Make sense? All right. So then what am I going to do? Well, I want to take whatever's in input 2 register. I want to add it to whatever is in input 1 register. And then I want to stick that answer into destination register. So we'll say destination register dot set value. And what am I going to set as value to? Input 2 register dot get value plus input 1 register dot get value. And we'll no longer modify our code here, but we will make some toast, Maddie. Toast dot make text this, call it execution complete. And this is toast dot length short dot show. So this will just put the little thing on the screen, like execution's complete. That way we know we can now click over and look at our registers and we should see the result. Right? Did I have to save the result in my registers? Didn't I have to do that? We had to do that on the other screen, didn't we? Yeah, well, why don't we see? We'll go and run this. All right, so there's all my pieces. I'll hit execute. Execution is complete. Oh, actually, I just added 0 plus 0 and got a 0. So this isn't going to really tell us anything yet. So let me go over to registers here, and then we'll just update our registers real quick. So we're going to say x1 is going to be a 3, x2 will be a 5. Okay, and we'll save those dudes. So now when we execute our code, we're hoping to get an 8 in x0. So we'll hit execute here. Says it's done. We'll go to registers, and there's our 8. So the question is why? Why didn't I have to save? Tell me why I didn't have to actually go back. Because what did we do before? If we remember on our register screen, when we hit the save button, what did we do? We went through, we set the value of all our guys inside of ARMAP registers, blah, blah, blah. Then we did the little toast thing, and then we pretended like the person hit the back button to send us back. Why didn't we actually have to do all that in our execute button here? Why did it just work? Somebody who hasn't answered yet today. This is a 200 and 250 concept. What am I doing right here? The high level, what am I actually trying to accomplish there?
You tried to add two numbers.
Okay, so I'm adding two numbers. So I'm adding the value of this register to the value of this register, and I'm setting the value of this register to that sum. But why did I have to go and save my destination register after this? Because right here, when I got my destination register, I retrieved it. I used my AR map find register with name. But don't I need to go and update the actual registers array? All I did was I set this guy's value to something, and I said it's good. And then we saw that it actually worked. Why is that? Go ahead.
Is it because you're actually changing it at the location instead of a copy of it?
Yep, this guy's a pointer. When AR map find register with name, this guy's going to return an instance of the register class. That is the identical instance, not a copy of it, but the actual same memory address as the register that actually lives in AR map's registers array. All right, so I get a little pointer up to this guy, so now I have two different ways to get to that guy. And if either one of them change it, we're still changing it up there in reality. That makes sense? All right, so that is add in our code here. Now subtract, I am almost positive that when I say subtract 3 from 5, well, if I say subtract, let's just go back here. It'll be easier for me to say it this way. So let's go here. I change the text in here to say sub x0, comma x1, comma x2. What I believe the behavior is it says x1 minus x2. So right now I had x1 was a 3, x2 was a 5. So x0 should hold a -2. Pretty sure that's how it works. Anybody confirm that, or should we go and look in the book to? Do anybody know for a fact that's how it works?
Yeah.
That is how it works? Okay. Yeah, so that's why I'm calling this guy input 2. So it's input 2 minus input 1 gives me my destination. Okay? As opposed to us assuming it's input 2 minus input 1 and giving us the wrong answer. All right, so what we're going to do here, we're going to go into our code and we're going to make this a little bit more generic, because right now inside of my main activity, I'm getting all of this stuff. So ultimately I have my instruction, I'm parsing it, I'm getting the actual magic trick, I'm getting the parts that are my inputs, I'm getting the register names, then I'm getting the actual registers themselves. So all of this stuff right here, even though it's a whole bunch of lines of code, each one of them is just doing a very simple thing, right? We're just picking out the individual pieces of our string so that we now have the parts that we need to do stuff with. Does that make sense? It's a little tedious, but nothing in those was overly complex. We just had to walk through it and do one thing at a time. But now after I have but we see this here, and we might say, oh, that's kind of scary. The code here might be kind of scary. So might it make sense for us to have like an instruction parser or something like that? Like an object that we could pass a string to called an instruction parser that ultimately spit out for us an instruction object. And what's an instruction object? It's the opcode and then the collection of inputs. Isn't that what that is? So let's go in here. Let's create a Java class. We'll call this guy an instruction. We'll add it to our Git repository. All right, so we're saying that an instruction is going to be a private string opcode. Or if we want to name it the same way we were naming it before, because technically opcode implies that it's already in its 11-bit binary representation. So why don't we call it a magic trick? since that's kind of a term that we're used to using. All right. So we'll say we're going to have the magic trick associated with an instruction. And then we're going to have a private. Now, if I have a collection of inputs, when I say collection, what should immediately pop into mind? What kinds of things do we have for holding collections of stuff? Arrays or linked lists. Okay, so the question here might be, well, how many inputs am I going to have? So currently we're working with some instructions that only take 3 inputs, but there actually are some instructions that take 2 inputs. Okay, yeah, like the shift instructions, for example. So since we don't know how many inputs we have, maybe we'll use a linked list so it allows it to grow or whatever. All right, so we're going to have a collection of, now, because we don't know the nature of those inputs yet, so kind of thinking ahead a little bit, if we want to write add immediate is going to have the first input, well, technically input 2, is a register, but the input 1 is a literal, right? So we can't just assume that we need a collection of registers. Really what we need is a collection of input values, and as a starter, we can just assume this maybe as a collection of strings. We're holding the names. We have a way of looking stuff up now. All right, and maybe if we go and look up like a 20, so if we have the literal value 20, and we go and look up a register named 20, and it says, I don't know what you're talking about, it gives us back a null, then we can just say, oh, it must be a literal, do something with it. Not sure that's really the most efficient way of writing it, but we could write it that way. So we're going to have a linked list of string data types, and we'll call this guy the inputs. Actually, it's not necessarily the inputs. We'll call this guy the components. Kind of like that. Technically, I'm trying to think, is there any instructions that there isn't a destination register? I think there's always a destination register. I think there is. So I'm actually going to call this guy the inputs. And then I'll create another private register, and we'll call this guy destination register. All right, so we're going to have a string representation of our magic trick. We'll have a register that is where we're going to put the ultimate solution, the result of our magic trick. Oh, hold on, it's not always a register. Because if we do a store, the destination is actually a memory location.
Yeah, but I think you still have register, but it's not that.
Yeah, it's a would be a bad variable name. Well, I guess we could say store it as a string. Say string, and then we could just call this destination rather than destination register. We call this destination name. Then call this guy the input names. And then depending on what the magic trick was, we can determine how to interpret destination name and input names. I think this will be a reasonable way of doing it. So an instruction is going to take in a string. It's going to do that parsing piece that we did. So we've already done the logic for it. We're just going to suck it into this object, right? So we'll go ahead and create our constructor here. So public instruction. This guy will take in a string instruction as a parameter. Okay. Very first thing I'll do is I'll go ahead and give my input names a starter value. We actually could have done that up here. I'll just do it up here so we're not taking the space up. So we'll say linked list of strings. Okay. So these guys are ready to store some stuff. Now I happen to have all the logic that we need there. Right here. So I'll cut that, paste it in here. So I happen to name my variable here the same as my one I did in the other place. So I'm dealing with instructions. So I get my magic trick, except it's not a local variable magic trick. Instead, it's going to be this dot magic trick. It's going to be, so now we have the rest, we have the parts. Our destination name isn't necessarily a destination register, but it's going to be a destination name. So I'll say this dot destination name is equal to whatever that first part was. I'll leave the example in there for right now. All right, now for my input registers, I'm going to go ahead and add them to my linked list. The reality is the way this actually executes is a stack. I'm going to do it as a linked list, just so we can keep our things ordered the same way we have them. So we'll say this dot the input names dot add so we will add our input 2 to our linked list. Similarly, we'll add input 1 to our linked list. All right, so we filled up our linked list now. We have filled up our destination name with the name of wherever we're putting this, which could be a register, but could also be a description of some place in memory. And we're kind of starting to get towards doing that. All right, then we also have our magic trick. Now I'm gonna delete, well, I'm gonna copy it just for a second, because we're not actually gonna do that in here. This is our setup for an instruction, okay? So now this instruction knows the magic trick, it knows the destination name, and it has the list of the linked list of inputs set up. So now I'm going to have another function here called public void execute. And this guy will execute an instruction. All right, so we're going to have a bunch of if statements in here that says, okay, so if this dot magic trick dot equals, and if we want to go the equals ignore case route, if we want to let them say add in all lowercase or all uppercase or something like that, we can do that. So if it equals add, then we're going to do some stuff. What are we going to do? We're going to get our 2 registers. All right, so we're going to get the destination register name, and it's going to be given the this dot destination name. Input 2 register will be find register by name of the input names dot get 0. And the second one will be the input names dot get 1. So that's our input 2, input 1. We'll just grab them from our linked list. So we're grabbing the strings from our linked list, and then we're still doing that register lookup that we wrote. Then we'll set our destination register equal to the addition of our 2 registers. That makes sense? So all the logic we wrote before is still here. We've just encapsulated it. So this is object-oriented programming. We've encapsulated this data inside of our instruction object. And what does that then allow us to do? it allows us to come out here to our main activity and allows us to say instruction I is equal to new instruction I can go ahead and pass it, my instruction here. If I want to keep the example here, I can. And then I.execute. So it allows me to do that. Have my execute button just be 2 lines. Create an instance of instruction, passing it my instruction, and then call execute on that instruction. Go ahead and run this. Oh, I changed it in here. I want to test it for add first before we. All right, so there's add. So we'll go and update our registers first. So we'll say this is a 2, this is a 17. Save, so we should get a 19 in X0 when we hit execute. And there's our 19. All right, so another example of kind of the approach of object-oriented programming, where when we look at our main activity here, this is a whole lot cleaner than what we had there before, right? But if we happen to pop the hood, where's my instruction? All the scary stuff is still here, right? We didn't do anything different. We just hidden inside the box. Okay, so else if this dot magic trick dot equals ignore case sub do something, else if add I do something, else if sub I do something. So this is write the code to subtract input 2, well, input 1 from input 2 and store the result in destination name. Okay, subtract input 1 from input 2, storing the result. Add I, this guy would be write the code to add input 2 to an immediate value and store the result in destination name. And this one would be write the code to subtract Does sub I work the same way? So if I say sub I x1, so x0, x1, 20, this will take the value in x1, subtract from it a 20, putting the result in x0, correct? So this will subtract input 2 from, input 1 from input 2. I'm going to say subtract the immediate value in input 1 from input 2 and store the result in destination name. All right. So for Tuesday, let me open up. Actually, let me publish this real quick. I'll commit. So now we are ready for add I, sub I. I need to force a push because I clicked the wrong button. Well, I'll put it up, but the next Bible homework is the next chapter in Acts, till we're done with Acts. Well, maybe not until we're done with Acts, but it is the next chapter in Acts.
Okay, I think the semester will end before we get.
Well, no. Yeah, but we're not just going to keep going in Acts because I think the section we're on makes some sense, but later on sections don't necessarily make sense. Let's see.
Just do Bible homework on every chapter of Proverbs.
Actually, would kind of be fun.
Okay.
No, week 1, Proverbs 1.
It's not a horrible idea, but maybe that's a next semester thing. It's a good idea. What content? This is program what? This is homework 10.
Do we have Bible homework in senior sem?
No. Well, not in senior sem 2. That's all project. You have enough work in there. You can still do Bible. You should read the Bible while you're in there just to keep yourself sane, but you don't actually. So write add I, sub, and sub I in our Android emulator. Android ARM emulator.
Like,
And this is due on Tuesday. At 1 p.m. All right, so questions about what I'm asking you to do? So the code should be updated on GitHub with our current thing. I've started our execute function here by putting in the else ifs for you. Now you have to write the logic inside of sub, add I, and sub I for our the correct operations, and whether or not you need to treat something as a register or whether you need to treat something as an immediate. And if it's an immediate, that means you'll have to parse the integer out of the string that's being held instead of looking up the register. Make sense? Questions, comments, concerns, bribes? All right. I'll see everybody on Tuesday.